Hello, everyone, and welcome to IAL Physics Unit 4. I'm Beanish, and in this lesson, we're diving into the exciting world of momentum. Let's explore how objects move, collide, and even explode, all while conserving something fundamental: momentum. By the end of this lesson, you'll be able to understand what momentum really is and how it behaves during collisions and explosions. We'll also look at both one-dimensional and two-dimensional cases, just like the ones that come up in your exam. Momentum is mass in motion. We calculate it using the formula P equals m times v, where P is momentum, m is mass, and v is velocity. Since it's a vector, its direction is the same as the object's motion. Think of a moving car. The heavier and faster it is, the more momentum it carries. Now, here's the core principle. In a closed system, total momentum stays constant. That means, when no external forces act, the total momentum before a collision or explosion is the same as after. This is what we call the conservation of momentum. Let's talk about collision types. In one-dimensional collisions, all motion happens along a straight line. In two-dimensional collisions, objects move off in different directions, and we resolve their momentum into x and y components. You'll see this in action in just a bit. Here's a classic 2D collision, where a moving particle 1 collides with a stationary particle 2, and after collision, they both move off in different directions. To check for conservation of momentum, we start by resolving the momentum of each object into horizontal and vertical components. Then, we add all x components together and all y components together. If momentum is conserved, they'll match before and after the collision, and that's your proof. Take a good look at the working shown on the slide. The conservation of momentum can also be shown using a scaled vector diagram, like shown here. Have a good look at it. What about explosions? Before the explosion, the object is stationary, so momentum is zero. After the explosion, fragments fly off in different directions, but their combined momentum still adds up to zero. No momentum is created. It's just redistributed to keep the total the same. Let's recap. In a closed system, momentum is always conserved, whether in collisions or explosions. In 2D collisions, we resolve vectors into components, and even when things fly apart, the laws of physics stay rock solid. In our next lesson, we'll look at energy changes in these events and Newton's laws from a momentum perspective. See you there.